Let identity function f mapping from r squared to r squared. So define identity by identity element x. Identity function x is equal to x for all x is an element of r squared. The identity function is bijective and preserves distances since the distance between identity function x and identity function y is equal to the distance between x and y. Therefore, the identity function is an element of A for any f or function f is an element of A, then f composition identity function is equal to f and identity function composition f is equal to f. Thus, the identity element exists in A. Now, let's go to inverse element. Let f is an element of A. Since f is bijective, there exists an inverse function mapping from r squared to r squared. So suppose U is equal to f of x and v is equal to f of y, where x and y is an element of r squared. Then inverse function u is equal to x and inverse function of v is equal to y. Since f preserves distances, the distance between u and v is equal to the distance between x and y, which is also the distance between inverse function u and the inverse function of v. Therefore, the inverse function preserves distances, since the inverse function is bijective. It follows that the inverse function is also an element of A. Thus, every element in A has an inverse. Therefore, A therefore A forms a group under function composition, and the identity element is the identity function, where every function in A has an inverse in A, Q, E, D.